All right, perfect. So this is our team and our presentation. So how we're going to structure this is we'll first talk about the overall flight ConOps and just how we see the launch, flight, and recovery all going. And then we'll dive into each of the systems, starting with structures, then going to avionics, flight dynamics, and then payload. And we can change that order up any way that you would like if you want to start from top to bottom. So this is the overall ConOps of the rocket. It's a pretty standard launch. The main thing that's going to be different is the ejection of the payload, and I'm sure that that's what y'all have the most questions about. So when we exit the rail, we should be traveling at approximately 100.1 feet per second. And after that, coast phase, and then we're targeting the apogee of 10,000 feet. And then shortly after we hit apogee, the payload will deploy. And so what's happening there is a motor is driving a rail system, and the nose cone is extending away from the payload airframe. And then the payload will deploy, and then the nose cone will retract back inside the rocket. And from there, the payload will eject, and they both will fall to the ground and await recovery via featherweight GPS. They're both going to have that COTS featherweight GPS system on them, as well as the Cricket, as we're designating it, as the ejectable payload will also have an SRAD component to it.
Okay, we're not going to talk too much about payload, but from a safety standpoint, I'm just curious. So originally we were talking about a significant number of these deployed little guys. What's the number we're talking about now?
One.
One is good. I like one.
Yep, we figured you'd like one, so we reduced it to save ourselves a headache and y'all.
Excellent. Next question is, at what altitude is Cricket being deployed?
So we're trying to get as close to 10,000 feet as possible. That can be changed though. What we're going to do is we're going to base it off of a timer after apogee. So once the rocket knows it's reached apogee, it's going to designated amount of time and then deploy. And that's the plan currently. We're still deciding on how much time we want to give it to allow for Drogue to come out and fully deploy before doing that.
So this shows the Cricket under a parachute, but I thought these were like little gliders.
Yes, so we changed the design. So we're not going with the NASA PCB glider design anymore. We're still partnered with them and using, bouncing ideas off them and working with them. However, they just weren't able to get the Space Act agreement finalized in time for us to actually get the hardware and the software, as well as the training needed to operate them and have a safe flight with them. So what we decided was to have an ejectable payload that deploys under parachute and should fall around approximately 20 feet per second.
So 20 feet per second at 10,000 feet. That potentially in high winds could be a significant distance.
That is true. Okay. That's something that we can look into. We haven't finalized the size of the parachute yet. We just went with something larger to be safer, but we can definitely decrease that or drop the altitude that we deploy at.
All right, so we're going to need to know that final disposition. Excuse me. We'll need to know the final configuration of that before you guys arrive.
Okay, we'll figure that out.
Okay, keep going.
I will say though that because there's a featherweight on it, on the Cricket, even if it is so far way away, it's not like we're going. Let's say it's a few miles. It's not like we're traveling a few miles in a direction to go grab a 60-pound rocket. We're going to grab a maybe a couple pound little drone thing. So it's, I can understand that concern, but it's not like we're going into the rocket.
No, the concern is we're going to have a team of recovery people that are potentially, instead of just being out on the field for, let's say 25 minutes, you guys potentially are going to be out there for over an hour or more.
Yeah,
trying to get out to that site. So
yeah,
again, the key piece is get everything on the ground as quickly as you can, have a very quick recovery, and let's move on to the other 100+ launches we have to do.
Yeah. And we also don't want it drifting onto someone else's property, especially if at 10,000 feet, 20 feet per second, that's a possibility.
So luckily we do have a lot of land, and you're not going to make it over the mountains, so that's good. But still, we'd like to get you in and out of there as quickly as we can.
Absolutely. Yep. We will finalize that and get you that data. Okay, so I'm going to hand this over to Sarah and Nathan, who are our structures lead. And Aaron and Cooper are in the shop, and we'll be able to actually show you what each of these components look like as we go through them. So if you guys want to take it away, go right ahead.
All right, hi, yeah, we're all structures here, and I've got Aaron, Cooper's over there. They also have a phone, so they can show stuff a little more closely. But for the motor tube, which we'll probably show you first, that's all carbon fiber. We have a motor tube carbon fiber, as you can kind of see in this clip, and an inner tube that goes around the motor. And then we have through wall fins that are epoxied onto the inner tube and epoxied again onto the outer tube. Seems very sturdy, very strong, went all smoothly. And that all went normally. And then for the rest of the body tubes, we have fiberglass. So we all of our tubes we make ourselves. That includes carbon fiber bulkheads that are epoxied inside. That's the old avionics and all that. And then we're gonna show you more. So
Is it flipped around? I can't see what it's screen. What do you see? Okay, that's it. Yes. These are the carbon fiber fins. And here's our G5000 epoxy that's affiliated to it. This entire tube is carbon fiber. And as right here, we have our inner motor tube, which is also of carbon fiber, and our motor end plate, which is carbon fiber. Essentially, the entire thing is carbon fiber. I'm gonna lift it up, show you inside. Well, parachute. In here, we have our upper bulkhead, which is where the lower attachment of the parachute will be. And that upper bulkhead is also the main motor retention, where the majority of the force from the motor will be applied to the rest of the rocket. Anything else?
Well, so I guess at this point, since you're showing us the rocket, you guys start asking questions about it. So, okay, I'm seeing a boat tail. That's great. So I was about to say that that motor mount sticking that far out is a little wild. So the boat tail will be acting as your motor retention. Is that correct?
Yes, that is correct.
Okay, so I don't see that it's actually installed yet. So I guess some concerns about, is that something you still have remaining to do?
Yeah, that's going to be 3D printed. And so there's a prototype, and the final version of that hasn't been printed yet.
So what material are we talking about 3D printing?
It's carbon fiber reinforced PA12 nylon.
Okay, so you understand that that is the absolute hottest location of the entire rocket, correct?
Yes.
So while carbon fiber can handle heat fairly well, the epoxy that holds it all together, excuse me, not the epoxy, but the polymer that's holding it all together does not handle heat very well. When we are looking at typical boat tails that handle motor retention, they're almost always some form of metal.
Yes. So there's also this upper bulkhead there's a bolt that's
Okay,
not
so you've got forward retention. Okay.
Yes, it's like minimum diameter retention and the boat tail, they are both holding it in.
Okay, gotcha. That helps. So I'm comfortable with that. The only potential other concern is ensuring that that motor somehow that when you insert it and you screw it tight, you make sure that that motor, there's no way in the universe it can vibrate its way loose from that bolt. That is super critical. And then also, where I guess with the motor casing, when you insert that motor casing into the back of that motor tube, this is Aerotech or Cesaroni?
Aerotech.
Okay, so the rear closure for that Aerotech motor should butt up against the rear of that motor mount tube. Is that correct?
You're like, so the top of the forward bulk,
I've switched back to the back one. Sorry, I changed subjects on you real quick. So when you're inserting that motor case into the motor tube and you got it almost all the way put in, the rear closure, meaning near the nozzle end of it, that rear closure should not be, I mean, it should be, I guess, stopping. It does not go through the body, that motor tube, correct? It should have a physical stop at that point.
correct. If can whoever's showing Aaron in the shop, can you go back to me see the motor tube again?
There's the motor casing.
Yeah, so
Just right in.
it slides in and it stops with that inner carbon fiber tube. It sits right on that.
Excellent. Okay, so that is where almost all of your force will be exerted through your rocket. So you have, I see 1, 2 centering rings. Is that correct?
Yes, the very far the rearward most bulkhead is a centering ring.
Yep.
It's 2 bulkheads, so the inner one is the centering ring, and then the outer one is the same diameter as the outer diameter of the body tube, and then another centering ring for at the forward point of the fins.
Okay. What is the thickness of those centering rings, and I guess how are you affixing those to the body tube?
They are both 5mm carbon fiber, and this whole inner structure is it's all attached together. So there's a fillet on the forward centering ring, and then other than that, it's just the fin fillets.
Okay.
But there's epoxy all around the inner tube to the fins, and the centering ring to the fins, and the centering ring to the inner tubes.
Okay. So the forward, the bulkhead just in front of the motor, how is that one attached?
That is also filleted in
Okay.
on the forward side.
And the same thing, 5mm carbon fiber?
Yes.
All right, that should be sufficient. What is the I guess nomination for it or numeration of it? An Aerotech M1390 or what is it?
M2500.
Daniel, you're pretty quiet.
It's an M2500.
Okay, so that's not a little bit of thrust. That's a pretty significant amount of kick off the pad. I just want to make sure that this thing is fully secured. If that was less than 2,000, I probably wouldn't have any major concerns with this. And even now, it's typically just minor concerns. So the fillets that I noticed on your fins to your body tube, those are pretty stout. Those are pretty beastie. Have you guys considered doing any type of tip-to-tip glassing of those fins?
We have, and the fin flutter calculations didn't show that we needed that.
Okay.
So we did not do that.
So the other thing that helps with would be, again, since you've got the centering rings, or you got the fins going through that, I guess where the fins anchor to the body tube, I take it all of those areas are epoxied as well.
Yes.
Okay, so tip to tip there would anchor it even more. Again, I'm not particularly concerned by this, and Anita's probably rolling her eyes going, "You're being silly, Andy," but I think we'll be in good shape with three centering rings and the size and scope that you guys are talking about. And it looks like you got a fairly serious amount of fillets in that. So as long as do you have any pictures of when you epoxied in those centering ring sections? I know it's hard as heck to get photos of that.
Yes, I have that. Anthony, is this a live version of the Google Doc?
What are you talking about? The presentation?
Like if I add a photo to the presentation real quick, can we?
Oh, yeah. It should be.
Give me a moment and I will get that picture of the interior for you.
Yeah, we have some good pictures of that. We also have a video of the process of us making that.
Okay.
They're pretty beefy fillets though.
Good. Yeah, I saw that one photo of them. They look pretty significant on the outside. If they're anywhere close to that on the inside, then I'm sure you guys are in good shape.
They're bigger on the inside.
Well, that's excellent.
Pretty
Okay.
sure.
Then yeah, don't worry about the photo then. Let's move on. Let's and stop me, guys, if this is further on in your presentation. But since these photos are so great, I really like to. So the motor casing itself is using one of those minimum diameter forward closure threaded rod connections. Does that rod go through that forward bulkhead, and does that connect directly to your eye bolt by chance?
They share the bulkhead, but the eye bolt is separate from there's a motor retention bolt and then there's an eye bolt separate.
So in future designs, if you think about it, you can't get a better anchor point than putting an eye bolt to the top of that motor case. So let's say, for instance, the whole rear end of that rocket shredded, and the motor case was free to fall wherever it wanted to. If it's got an eye bolt going to a shock cord going to a parachute, then you'd have little thin light pieces parts of your fin can falling to the ground, but that very heavy metallic motor case, more than likely, hopefully, still under some form of a parachute. Again, for future designs, instead of doing a separate bolt, just have a single bolt with a bunch of washers and nuts and such, and put an eye bolt towards the end of it, so that you could just attach your shock cords directly to that. That would make it very, very well anchored. It would also transfer a lot of the force away from the actual bulkhead and leave that force in the motor casing. So it would literally have to pull the motor casing all the way through that body tube to get the parachute to come loose.
Okay, we will look into that.
Yeah, no, that's good advice. We'll definitely keep that in mind in years future and see what we can do this year.
Launch lugs. So can we talk about launch lugs?
There is so for there's a lower launch lug. Cooper, if you want to get us back to the video, there's a threaded insert that's epoxied in between the fins. Like I can't remember the exact dimension, but it's the lower one, Cooper. Yep. Right above that bottom bulkhead, and there's a threaded insert epoxied in beneath that, and then that one just simply screws on, and then the upper one is just that there with a nut on the other side.
Okay, so recommendation from our side, instead of just a nut, if you add a washer especially a really wide washer, maybe bend that washer so it sort of maps to the inner diameter of the tube. Also, you want to cut that the dimensions. You don't want that nut sticking that far down into it because it can cut shock cords and create all sorts of havoc. But again, the key piece is if I were to grab that rail button with a big pair of pliers and just pull on it as absolutely hard as I could, you want to make sure that it, before that thing would actually come out, it would take a large chunk of that body tube with you. So a nut by itself is okay, but a nut with a big washer, man, that's awesome. Okay, that shouldn't be too hard. I mean, from that standpoint. And also the other piece is just make sure that inside the body tube, you don't have a 1/2 inch or even a 1/4 inch of excess threaded nut sticking down, because you don't want anything that sharp metallic that could be snagging shock cords or cutting shock cords or ripping parachutes or anything else like that.
Yeah, we were planning on grinding down the nut.
Perfect. Yeah, good deal. Good deal. Okay. All right. Now you have to go through Anita's fin flutter test. So I will hand it over to Anita.
Okay, so you guys go back to the fins and take one fin in one hand and the other in another one and try to flex them together, apart.
Push them.
Push them.
With them?
Yep. Push down on it. You're good.
Looks solid to me. How fast is this rocket? What's your max velocity?
It's about 960 feet per second, so around 1,000.
Okay, so you're sub Mach, so that should be good.
The factor of safety for the fin flutter, I believe, was like 5 point something. It's in one of the later slides.
Yep. Well, we love mathematics, but squeezing the fins together seems to be a pretty surefire method as well.
It's also capable of, if y'all have seen Joe Barnard's video doing his fins when he like stands on them, it's capable of surviving that with about 170 pounds on it.
Joe Barnard, that's that guy that's trying to land a rocket, right? What does he know, right? Yeah, if you want a real expert on building super thin, super high performance fin cans, you want to go talk to the man, Jim Jarvis. He's the 2-stage guru, and he can school you in that kind of stuff. Super thin carbon fiber that you can stand on all day long and still look pretty too, which is even more amazing. So, all right, I'm good with the fin can. Oh, the eye bolt. I'm sorry, we didn't get an actual chance to see what the eye bolt configuration looks like. Do you have either an image or can you get the video camera down in there? I'm not sure. Pretty dark when you were showing it to us before.
The bolt would be in the middle attaching to the motor, but we don't have that in there.
Gotcha. All right, so is that a forged bolt?
Yes.
Okay, do you have an example of one of those somewhere else on the rocket?
We're grabbing one.
Excellent.
I think. Is it the eye bolt or the bolt? All right, that means let's get to the eye bolt, right?
Yeah,
You want the eye?
the eye bolt.
Oh.
I just want to see the size of it. Make sure that it's fully closed, it's forged, it's single piece.
Is it the same thing? No. It's the big one.
Okay, excellent. So, and those things are probably rated to 2,500 to 3,000 pounds, somewhere in there.
Yes, I believe so.
Yes, 3/8.
Yeah, those are big ones. We like those. All right, what about your D-links? All right. I'm liking all those. Those look good. When you close those up, make sure you use some form of a pair of pliers or something. Don't rely on just your finger tight on any of those D-links. You want to tighten those down with a pair of pliers so that it takes a pair of pliers to undo them.
Okay.
Okay. Sounds good. And that's I guess the same throughout the rocket, correct?
Yes.
Okay. All right. If you guys want to get back to the presentation, or if you just want to continue on with the physical rocket review.
I think the combination of the two is probably best. That way we can use the presentation to kind of label some things.
Good.
So especially with assembly of the avionics bay, I think that this would probably help the most. And I know Aaron can speak on behalf of this the most.
Yeah, real quick on this image.
Yes.
If you look at those eye bolts, and I know the eye bolts that I've seen are not the folded over kind. Those are the bad ones. So
Okay.
I would get this image updated so that it doesn't show the folded over ones, because those you will, if you show that to any range safety officer, they're going to have fits.
Okay. Yeah, that was probably just the wrong CAD grabbed
Yeah.
when putting this together.
Okay.
We'll get the Photoshop magic out and fix that.
Very good. Very good.
Okay, so Aaron, do you want to talk about assembly of the avionics bay?
Yeah. So here's the bay, you see in the picture. This bottom, we have pick one. We have the
Eye bolt mount right here. It's threaded into the bottom mount. This mount is made of ASA plastic. This bottom is where you see in the CAD the eye bolt will screw into. So we go to the tube, which is made of fiberglass. Thing we talked about earlier. It's going to insert in like this. Right way. We attach the pyro charge connection right here. And then just kind of maneuver it in. Kind of got a lot of loose wires right now. And then we'll flop the eye bolt mount into the bottom. Here. Slides in like that. As you can see right there, we'll have the hole to the left is where the eagle will slide into. And yeah, right
So
here at the top is where our pyro charges connect.
Yeah, you got dual CO2 systems, right? For both the main and the other?
Yes. So we'll have, so the eagle is the Drogue. It's the Drogue deployment.
Okay.
And we have a tender descender, which I could show you in just a second. Is how we are deploying our main at set Apogee.
Well, that's not what your presentation showed. It showed,
in that CAD model, it doesn't show the tender descender, which is our way for showing our
So you've got both parachutes coming out of the same orifice.
Yes.
Okay, because I could have sworn I saw something different, but wait a minute. Nose cone opens up to deploy the payload, the cricket, and then closes back up.
Yes.
But
that's
nothing else.
after-
Right, nothing else comes out of the nose cone. Is that correct?
Yes.
Correct.
Okay.
So let's fix this and then we'll show you how it all connects together. So the top here, we have little screws to put our holes.
And so those are going into some kind of mount, I guess, that's inside of there. Is that another centering ring?
Yes, there's an upper ring which the upper bulkhead right here sits on, and these will screw into that. And that ring is also the threaded inserts. Screw into the threaded inserts. And that ring is also mounted in with the same epoxy used for the fins.
So is that one ring the only piece that's holding your avionics bay into that tube?
No, it also has that bottom bulkhead, which the mount sits on,
Okay.
which is made of carbon fiber and it's also mounted in the same way.
Yep. Okay.
And that mount will keep it from moving horizontally in flight, keep vibrations minimum.
I see a nice U-bolt in there. That looks good. What's the back side of that U-bolt look like?
Sorry.
On
Can you repeat
the opposite side of that U-bolt on the centering ring, excuse me, not centering ring, on the bulkhead, what's keeping the two sides of that U-bolt anchored?
This ring right here.
Yep.
There's two other bolts connected to the same connector to that mount that we saw.
Again, I would definitely identify some washers in there.
There are washers on there.
Yeah, make sure they're fairly large so that they disperse the impact is to a wide enough area from that. But a U-bolt is still a good scenario for all of that. Can you
So
talk to me?
that's not the parachute mount. The parachute attachment point is on the other side.
Yeah. That's just for us to convenience for taking it in and out.
Oh, okay. Oh, I'm sorry. I thought that was this is the side. I got you. Okay, you're right. Everything's coming out one side, and that's the side with the CO2 system.
Yep.
Yeah, we'll
Okay.
show you the eyeball just in 1 sec. Just connect it to the. Oh yeah. Here it is. This is the eyeball. It's going in here.
Yep.
So it's going to screw in to this bottom. Oh my goodness.
So same situation with that. When you're installing that prior to launch, you want to absolutely make sure that that's not going to come unscrewed. So
Oh,
if you want lock washers, Loctite, anything you can do to keep that thing from accidentally unscrewing, you need to plan.
Screw in like that. We would tie it in after we screw it in to prevent all this twisting. But to save time, we didn't do that today.
All right, so I see the two holes for the CO2 system. I see the eye bolt. What's directly above? Is that another eye bolt or what is?
Yes. So for our main deployment that you were seeing earlier, we have this tender descender, which is essentially a cutting link. So this is our main chute right here, and it would be bolted into that, or connected to the E-links, connected to that bolt, holding down this the main parachute for a delayed deployment.
Okay. And that D-link being the smaller one, all that in the end, all that will hold back is the bag, correct? That's not gonna hold the weight of the entire rocket.
No, just the bag, yes.
Gotcha, okay. All right. Eeny, meeny, miny, mo. So let's, at this point, the tender descender is in, you've got your shock cords. What's the length of the shock cords we're talking about?
This one is 10 feet,
Okay,
if I remember correctly, and this other one is 30 feet. And this one is connected to the motor tube, and the drogue will be connected to the E-link right here.
gotcha, okay. All right, so we got the connections. The size of the drogue, is that your drogue right there?
Yes.
Okay, so that's, I guess, orange and black, or red and black. What is that? Is that like a 4-foot iris?
48.
Yeah. Okay, so 48, and then what's the size of your main?
Ooh. I think 10.
120 inches.
Okay, so 10 foot. All right, and you already got it in a deployment bag. Do you guys have experience with deployment bags?
We used one last year.
Okay. All right, so again, just be careful in packing those chutes. You know, if I'm gonna fly, I'm gonna make sure those parachutes are out of the bag for at least 24 to 48 hours before the launch. You want them dried out, you want them in their natural state. I would not put them into the bag like you have it now. In fact, normally during just normal business operations, I would never even store a parachute in a bag like that. Because if it sits in there for more than 12 to 14 hours, it'll start creasing and you get a potential risk that it won't fully open up from that standpoint. So I like hanging the parachutes from the top, you know, leave them in one of your I guess room, the hotel room or where you're staying. You know, make sure that it's out and accessible to the air. And then before you pack it, you may want to throw on some talcum powder or something to dry the parachute out. Make sure that it's very loose and easy to work with, so that there's no hesitation when it finally gets released to the air during your launch, that it fully opens up.
Yes, sir.
Okay, Anita, what am I missing?
What color is that main parachute?
Orange and purple Clemson's colors. It was
Okay.
$40 extra to get the purple, but we needed to do it.
Yeah, I mean, I get it, but the orange and black on the other one there's a lot of orange.
Yeah.
Yeah, the key piece is when we're watching the rocket, and this is a 30K launch, correct?
10K cots.
Oh, 10K, okay. Did you guys change your category or were you always 10K cots?
We've been 10K cots for the full time this year. We were 10K cots last year, and in 2019 we were 30K cots.
Okay, all right. Well, yeah, and so when we see parachutes come out, it's good to be able to determine the you know, whether it's the main or the drogue by the colors. And
Okay.
you see one is like, oh, that could be the main, it might be the drogue, we're not really sure. Then you know,
Gotcha.
it opens a lot of confusion. So
Okay. The reason why we have the black and orange one is because that's a parachute that we had from years prior that we hadn't used. And so just monetary reasons, that's why I chose
no,
to use them.
it's all good, guys. We'll make do, but it is an FYI and a point that Anita has brought up other reviews, and it's very valid. So
Yeah, no, that's a very valid point.
talk about the avionics now. So let's pull the sled out and let's look at your flight computers and wiring and all the fun stuff that goes along with that.
Before you pull it, I'll just say that I did have to take it apart recently and undo a lot of the wiring, so I don't believe a lot of the wiring is fully there, but I can explain anything you want to know.
Yeah, I'm noticing the switches look like they're out too, or
Yeah.
have you not installed those?
They were installed and then I had to uninstall them to rewire it to make it a lot less wires and more compact.
Okay. While you're doing that, I'm going to ask a question about the cutout. So I'm seeing 3 square cutouts of the body tube and also the coupler for the nose cone. What exactly are the details of that?
So that is for the camera bay. We have a 360-degree view of the camera. Thank you. So that's just a viewing port for them, and they stick down into the coupler and then out the avionics tube.
Nice.
And we'll clean the edges up.
Okay, so let me just throw this out because I've only seen a few teams that are actually doing onboard video, which is just a travesty.
I know.
There should be a law, you know, and there will be a law next year. Teams, I think, are going to get a 50-point bonus for having onboard video, but you have to provide us a copy of the video. And then if you happen to have, I don't know, a 360-degree camera, it may be a 100-point bonus.
Awesome.
So,
Yeah, so we plan to have 7 cameras on this rocket. So hopefully one of them will work.
one of them should get you a good view. Excellent.
Yeah, we're gonna have 2 Raspberry Pi cameras, 3 GoPros, which is that 360 view. They're each 155 degrees. So the idea is that because they're 120 degrees apart, we'll be able to stitch them all together into
Nice.
full
Yep.
360. And then 2 exterior run cams that will be in the shroud, which is still being developed.
Copy that. Again, I'm not always a big fan of cutting large holes in the body tube, but if you're going with a camera, I'll let it slide.
Awesome. We were very nervous about cutting those holes. We did. There was a lot of thought that went into placement of how far down. And
Now, again, when you do mount that, how many different screws? Because you're going into blue tube, is that correct?
correct.
So what is the weight of that nose cone section that you got? I mean, that's got your payload, so we know 8.8 pounds plus whatever the weight of all the other stuff.
Right. Do you guys have? Can you guys measure that currently?
Yes, give us a second.
I just want to make sure that however you're securing that nose cone assembly to the body tube, that it's maybe a little bit better than just a couple of maybe screws going into blue tube.
Okay, there's an aluminum plate that they're going into. There's a bulkhead
There's an
right
aluminum
there.
plate underneath it?
Yes. We'll
Oh,
talk
okay.
about that.
Oh, no, okay. We're good now.
Yeah, there's an aluminum plate here and another one here that
Perfect.
connects the two.
Good shape, good shape. I like it. Okay. All right, excellent, excellent. That mechanism that I guess ejects the drone. I'm sorry. Once you have the avionics out, tell me so we can start taking a look at that. But in the meantime, I'd love to see that drone. So the nose cone out comes loose.
Yeah.
Those come from those hole.
Do you guys have the threaded insert in or no? Or not the threaded insert, the lead screw?
We don't have the lead screw in.
The lead screw's not in right now.
Okay. No, that's good though. That'll show. Actually coming apart. Okay. So I'm gonna pull up the presentation again, just so that you can have hopefully a clear understanding of how this works. So the nose cone is fixed to, or Sarah, you can talk about this. You're payload lead.
So the nose cone is fixed through epoxy to a carbon fiber ring as at the end of the coupler that's built into the nose cone. And on that ring, there are threaded inserts to where the cricket shelving unit also has a carbon fiber ring that lines up. So the inserts are like aligned, and then you screw those in. That's how that secures. There's also it's not necessarily labeled, but these blue squares going between the shelving unit and the edge of the tube, those are screwed in. They are fitting to the side of the tube, so that makes a snug fit for those linear rails, so that will minimize any rotation in the payload. And then, as previously mentioned, there's the two aluminum bulkheads on either side of the camera bay, screwing in from the outside.
So I guess at this point, you would, when we get to the point of deployment, an electrical motor turns the lead screw, the nose cone separates or I guess extends from the rest of the body tube, and that exposes the cricket shelving unit to open air. Is there a release mechanism, or does it just sort of fall out?
Right now, it is held in the tube through this little door mechanism that they're kind of demonstrating there. And then as that shelving unit moves up, the door flips open, and then that is where it would be released. So then it's also made to where when it slides back in, as seen there, it shuts to minimize any jamming.
Okay. That's pretty fancy. You got to be able to, okay, I'm just throwing this out for Tuesday's presentation for the judges and also for range safety. You got to find out a way that you can activate that, because they're going to want to see it. They're going to want to see it as bad as I want to see it right now. So
activate the whole payload deployment, or just that little
absolutely
door?
you want to,
okay.
It's like having a transformer on the table. You know, you guys push the button and it transforms into something cool, and they're all like, wow. So I mean, that would be again the little kid in me coming out, but I guarantee you that there's a lot of the blue shirts running around that would be pretty impressed by that.
Yes, sir. Thank you for letting us know that.
Yep. Okay. We're good. Can we look at the avionics?
Yep.
He said it's not complete, right?
Yeah, Kyle's mentioned it's not complete.
Yeah, so like I said before, there's a lot of stuff that's not on there currently. Most notably one of the flight computers, and also both custom printed circuit boards we've designed. But I mean, I have slides in the presentation, but if you have any immediate questions, you can ask. Oh, also the Stratologger is not on there as well.
Yes.
Okay. So let's start out with the basics.
Yeah.
I think you do win the award for the absolute longest avionics sled. I don't know, Anita, have you seen a longer one?
I have not.
Okay, congratulations. I'm sure there's some kind of award that you guys can get for that. I'll have to find one, but anyways, primary flight computer, your commercial flight computer, what is that?
So COTS system is a Stratologger CF. It's one of the ones that we ran last year at Spaceport. That worked well. That runs off of a 9 volt 1000 milliamp hour battery that we found last year. It lasted for over 4 hours and did a great job. And then for COTS GPS, that's the featherweight COTS system, as I'm sure you have probably used before. That's running off the standard featherweight out of the box. I believe it's 400 milliamp hour battery, and that is rated by featherweight in the manual to last for approximately 16 hours. So more than enough.
Okay. And so you're going to have two different Drogue deployment CO2 systems, correct?
Yeah, there are two different Drogue deployment systems.
Okay,
correct.
so the Stratologger will be connected to one. What will be connected to the other?
So all of the Drogues, all the deployment systems. Aaron, can you show the DB9 connector?
Yeah.
On the other side. We moved it. I forgot. Sorry. So that connector runs all of the parachute lines through it. So all of
They run through
all
this all the way down
yeah. Can you show the screw terminals, please?
to the bottom here.
Okay. Can you show the screw terminals on the bay though?
Yeah.
Okay. So all the parachute lines run into there for all the systems. So the Stratologger and the SRAD flight computers will be hooked up to the same charges. Because unlike the Raven, I believe, the Stratologger can't do like a delayed second charge for like a Drogue or something. Each SRAD flight computer will have a backup charge which they can fire, which will be on a different line, I believe.
Okay, I guess the key piece that I'm worried about is with all the SRAD stuff that you have thrown around there, is there, I guess, any of that, because I'm seeing MOSFETs and all sorts of interconnections. I'm totally okay with that, but I want to make sure that we're not building in some type of advanced capability into the standard Stratologger CF function.
No,
Meaning-
no, it's the Stratologger gets power, it gets all of its enables correct, and then its lines run straight to the parachutes with nothing in between, except for the connector, obviously. Yeah.
All right. So I was looking at the DB9 inside the rocket, that one that's over there on the right with the orange wires in it. So please be careful on those kind of things. And again, I'm not going to hold you accountable for what it's doing right now, but do you see where all those wires are exposed and sort of wide open like that?
Yeah,
That
originally, can you hear me?
that's a nightmare.
Originally, it was like this, and there was tape separating them. But as that's
all right, so let me just give you a little guidance on that one. You want to cut off just enough wire and then fold it over maybe once or twice so that it fits in there. And so you shouldn't see any bare wire. I mean, the bare wire should be inside the pinch part of each one of those connections. And then the moment that the connection, the physical connection point is gone, it should be straight into the insulation. That helps you avoid two wires accidentally crossing over. So, tape, trying to get tape in between each one of those little notches is going to be a nightmare. It's going to be a mass of tape. So I love those things to a certain point, but I also dislike them greatly because of that challenge. So the other piece of that is all the wires coming out of that need to be in a bundle set up so that there is no flopping around. That's a key piece. And then the final test is to, basically yank on them. Once you got it all set up the way you want to, you want to pull on them. Every connection point, you want to pull up, make sure they don't accidentally come out.
Okay.
Sure.
All right. Okay, so tell me a little bit about your SRAD avionics.
So the SRAD flight computer, it's a dual system. They're both Raspberry Pi based, as you can see. So we chose Raspberry Pi because it allowed us to use Python, which we felt we used to work in a lot of C and C++, and we felt like we didn't have a lot of that low-level skill set anymore. So we liked Python to give us more of those abstractions, which we found were useful.
Right,
even
you
though
guys
Python
understand the difference between Python and C, correct?
Yeah. Yes.
One is interpreted and the other
Yes.
one's not. So
yes, I understand that.
yeah, and same thing with the Raspberry Pi. It's an actual computer. It's not an actual processor.
Yes.
So you got a lot of overhead on both of those. I don't see a lot of teams working with Raspberry Pis. They're usually considered too much overkill, I guess, too many extraneous functions that aren't really necessary. And they don't come with any sensors, which is another pain in the butt.
So that's true. Next year, we have plans to go to STM32 processors with full customized printed circuit boards.
There you go. Okay.
But this year, it's not on there right now. In fact, right now, we just ordered this afternoon another revision of the design. We have a new printed circuit board, and that slots in on top of the Raspberry Pi and in the GPIO pins and all the other pins that are on the Pi. And that's why we have that little piece of tape, is to stop it from possibly shorting across the USB and Ethernet connections. So that has all of the sensors, and it also does deployment charges, and then our buddy comm system and anything else.
So is that a
that we-
custom design system, or is that like a hat that you got from someone?
So originally we were going with the Sense hat just because of ease of use. We were trying to start out small, build something that definitely would work, and then go from there.
Yep.
We found we kind of like graduated that pretty much in like a semester, and so we made our own PCBs, ordered them, or designed them and ordered them, and we've tested them, and all the functionality works. So that's fully tested there.
Okay. I love that word, fully tested.
Yeah, but
In my mind, fully tested means you put it in a rocket and you've launched it several times.
that's tested for capability.
Okay. How about tested for flight?
Yeah, so while we were not able to do a full flight test, we've done both a vacuum test, and we had our kit rocket tests. So I guess that was a flight test, but it was a kit rocket test in the
Oh,
fall.
okay. So that's cool. You put it into a kit and you launched it.
Yeah, and that was back in October. So I believe it used the Sense hat, but I mean, if anything, the sensors got better from there. So
Okay. So
we're
again,
pretty happy with that.
the coding is always the challenge, guys. The putting the hardware stuff together, that's about 30% of the challenge. But when you start pulling in, all these different sensors, all those different inputs, and then trying to filter them to make sure that they're accurate data, and then trying to drive actions off of that. What are you using for your filtering logic for that?
So a lot the components we're using a lot of like breakout board stuff that does a lot of that filtering on board, the SOM, system on module. So it deals with a lot of that for you. So by the time it gets to the flight computer, it's actually pretty decently filtered for accuracy and precision. But we still do some onboard. We take a lot of medians between data ranges, so that we can we can deal with outliers in data and not overreact to certain measurements. Additionally, per Ezra's recommendation / being voluntold, we're arming when we power on, and that's when we're vertical on the pad. So there's no special logic that's needed to be armed or detect a launch besides a sustained upward acceleration,
Okay.
which, since we're already vertical on the pad, we should not be experiencing until we launch.
Okay. All of those sound great. I like that general idea. Two quick questions. So when you're doing your testing, I love having a commercial flight computer right next, like say for instance, you just create a small vacuum chamber. Putting a COTS flight computer like that Stratologger right next to your SRAD, and then doing a compare and contrast to see how close your data looks to the commercial data.
Yeah.
Were you guys able
That's
to
a
do
good
something
idea.
with that?
I don't think we thought of that, honestly, but that's definitely a good idea. I'm wondering if we'll be able to institute it given the requirements, like being a shop vac. I don't know if we'll be able to do that in New Mexico. I'm not in town until the night before we leave. So I'm not sure if I can do that explicitly, but that's definitely a good idea.
So I would highly recommend doing something
Yeah.
like that if possible, any way you can. Next question. The Raspberry Pis, I don't think the processing will be overwhelmed, but the ambient temperature inside that avionics bay could be really nasty.
Yeah.
And
So
you don't have a fan on that one. How are you mitigating temperatures?
So two things with that. We found through both documentation and experience that when the Raspberry Pi starts to get really hot. The only thing, unless it's hitting like 100 Celsius or something like that, the only thing it's really going to do is slow down the just slow down the processor, which, like you said, is like not something we're gonna have to really be worried about with the processor being overwhelmed. Additionally, we did the thermal battery drain testing on the Raspberry Pi, like Ezra wanted in the second progress report, and so we were able to hold the Pi at about 102 to 104 degrees Fahrenheit for 5 hours with 0 hiccups. We have a YouTube video of that, and we have the data file for it during that test. And so it was able to go 5 hours, and we really only ended that test because it was like 8:30 at night on a Sunday, and we all had to do homework.
So the 102 to 105, where did you guys come up with that number?
That was recorded. So we recorded off the thermometer on the Pi, and then also the thermometer that's in the processor that's taking the processor's temperature. So we had a hot plate, and on top of that hot plate, we had a bucket that was like a plastic bin that was rated to that temperature. Then we put sand and plastic wrap over that. We put sand in the bucket to give it some thermal mass, and plastic wrap over that to protect against any like water that might condensate or anything. And then we placed all the electronics in there, including the stratologger. And then we fed all the data back to a laptop, and then used the laptop's camera to record it all, and had an iPad set up that was giving the real UTC time, I believe.
Interesting. I'm just throwing this out here, guys, because inside an electronics bay, there have been temperatures that have been recorded and provided back to us of 125 to 135 degrees.
Fahrenheit?
So if you picture, you know, the inside of a car sitting out in the parking lot in the middle of the summer, and hopefully we're going to be processing through these rockets a little bit faster, but there could be scenarios where you guys are sitting out in the pads for an hour. And so you understand what the inside of a car feels like after an hour. These rockets will be exactly the same way. And if the ambient temperature outside could reach 110 to 115 degrees, you only imagine what the temperature inside that rocket's going to feel like. So we know the stratologgers can manage that. Stratologgers really have no moving parts, so they're very straightforward. And I've had that out in the Black Rock Desert, you know, dealing with, you know, extreme temperatures many times with no problems at all. I'm not so sure how a Raspberry Pi is going to react. You know, when you start talking about all it does is slow down processes, well, I mean, if it can't bring in enough data, I'm hoping that it will essentially shut itself off before it'll decide to eject stuff.
Yeah, so it basically just decreases the clock speed. That's all it does. And then it'll thermal throttle itself essentially. And then obviously if it gets too hot, it will just shut itself down.
Okay, as long as we're comfortable that when if it does attempt to shut itself down, that it's not going to fire off ejection charges.
Yep.
I'm comfortable with that. That's why we have a COTS solution.
Yep.
All right. Connection points. So the worst thing in the universe for a Raspberry Pi is all those horrible little mini connection points. You know, you got USBs that are plugging in, you've got all these other things. So shake, rattle, and roll test on your avionics sled, very important. When you get it all put together and you get, you know, all your systems working the way they're supposed to in a rocket, if you've got a shaker table or if you got something similar to it, you need to start putting that through some pretty significant testing. You want to double check all your connections. That USB connection to the Raspberry Pi is probably one of the strongest ones Pi has, but it would still potentially come loose in a bad scenario. So you want to secure all those down. I use lots of hot glue and zip ties just to make sure that everything is out of the way. But to also keep in mind, you're going to be asked to pull that thing out of your rocket probably several times during range safety inspections. So I understand, you know, locking it down versus having it available, two different challenges.
So not all of the zip ties and everything that would usually be installed and they're
Yep.
currently installed because I had to take a lot of it apart.
Yeah,
So I
understood.
know there's at least like 2 other zip ties for that USB that should be there.
Okay. All right. Anita, what am I missing?
Kyle, would you like to show your slides?
Oh, I mean, sure. I mean, it's a lot of what I just talked about. And I mean,
I think you covered everything, avionics and other attachment points. I guess that tentative sender, we've asked a couple of teams, is it SRAD, is it store-bought? What are we kind of looking at there, I guess?
What was the question?
I believe that's
Is that actually a tender to sender, or is that something y'all made?
no, that's
No,
a tender to sender.
Fault from Tinder Rocketry.
Okay.
Okay.
So you want-
Have you guys been able, no, that's fine. Have you
Okay.
guys been able to do deployment tests with your whole CO2 system with everything packed? I know that's just gonna be on the ground, but that provides, vital information.
So
Uh,
we did one test with an empty system. And
with
we
the
had,
lower.
yeah, you talk about it.
Yeah, we did a test with a 33 milligram or 33 gram CO2 cartridge, and it sheared our pins or sheared the shear pins. But we plan to use a 45 gram CO2 cartridge, and everything will be packed as well, so it will shear with no problem.
So I would test that just to make sure, get it on video. If you want to test it actually out there on site, we will have a situation, we will have an area set up for that. But again, don't fly anything that you haven't tested the ejection charge system completely. So that is going to be a question. I'd prefer you do a test before and on site, because that way, if anybody, the range safety team asks, you can immediately say, yes, we've had a full dress rehearsal and we've had successful ejection charges. You tell them that and they move on to the next point. Anything besides that, like what you just mentioned to me, where you tested it with 30 gram and you're gonna move to, that brings up question marks and that'll have them start digging into it. So again, if you wanna be safe, I would start getting to work on trying to put together a full dress rehearsal ejection charge before you depart.
Yes, we plan to, once the boards for the avionics are built, we plan to do a full-on test, including with the avionics bay inside, so we can knock everything out in one time.
Yeah,
Copy that.
currently we're just waiting on the new printed circuit boards to arrive. They were ordered this afternoon and should be there in a week.
Just to let you know, guys, we've got a couple weeks. I mean, y'all are really late in the game to be working on this kind of stuff.
We were trying to order them a couple weeks ago, but we were having some logistical issues with it.
So let
Can
me,
we do
let
a
me
test
highlight-
without the SRAD system, guys? Do we feel comfortable with that?
We could do a physical test.
I think that's a good idea.
yeah. And so let me back up a little bit and try to explain why some of the frustrations I've had in the last 3 or 4 teams I've done reviews with. You guys, I mean, we announced the event in October. You guys submitted your applications, or in the November, December timeframe. We announced the winners in December. In I guess January, we did the or in December we did the first interim progress report. That's considered a preliminary design review, meaning this is generally what we think the system will look like. And then a few months later, we asked you for a updated or a critical design review, which is again a second interim report. And that's, hey, here are all the things that we addressed from the first one, and we're for the most part done building everything. So this is a final check on everything to make sure we're solid. What we're doing now in the final review is a flight readiness review. This thing should have been finished built a month ago. This is where teams are doing flight testing, not putting together circuit boards for SRAD avionics. So yeah, I'm a little more than deeply concerned that you guys haven't finished that kind of stuff and you're waiting for parts. Telling me you ordered them a couple of weeks ago doesn't really help.
No, we already had the boards before. We just wanted to make improvements on them and do optimizations. So there are
Okay.
already boards there, but we felt that a test on boards that aren't going to be on the final rocket wouldn't make sense. So we wanted to wait for the new ones anyways.
All right, so focus on some project management in the future and make sure that you guys have final, basically your rocket is 99.9% built and ready to fly by the end of April at the latest for next year and moving on. So, all right, off my high horse. It's just a little frustrating when we can't confirm all of this kind of stuff. But the whole process for this video review is to catch things like this. We have had so many teams show up to New Mexico and still be epoxying in their fins that you don't have sliced. I mean, oh my God. And there's nothing really we can do as long as they still pass the range safety. So, all right. Anita, is that good for you?
Yeah. What size shear pins and how many are you guys using?
256, and we're using 4 of them.
Sounds good to me.
Okay.
All right. Anything else, Anita, you want to take a look at before I get on my spiel?
That Drogue, are you guys using a parachute blanket for it? Like, how are we protecting those? I saw the main, so I know how that's going.
But
If there's not a parachute blanket on there right now, we have parachute blankets that we can put in there.
Okay.
I'm pretty sure there's one attached to it.
Yeah, they're using CO2, so there's no burning.
Oh yeah, that's true. That's true. Sorry. Okay. I think that was my last question.
Yep. The CO2 cartridges themselves. I don't know if you guys heard about the incident a few years back where a vendor had a CO2 display of CO2 cartridges sitting out in the sun, and one of those lit off. It heated up and it lit off. And those little boogers are a lot more aerodynamic than you think they are, because it proceeded to bounce off of 2 different vehicles, and it missed one of the student teams by a few feet. But it will definitely leave a bruise, and if it hits you in the right spot, you will likely not be, you'll likely be leaving this earthly planet. So you want to be very, very careful with those CO2 cartridges. They're not black powder, but if they're left out in the open sunlight, they will cook off, and that will not be good. All right, into that spiel. All right, a couple of questions for you. I think physically looking at the rocket, guys, you're in fairly good shape. Obviously, a couple of questions on that. If you can finish up the testing on your avionics, get your ejection charge testing going, you'll be in fairly good shape. Follow some of the advice. I mean, go back over this recording, write down your notes, and maybe a little bit of additional heat testing on the SRAD on that Raspberry Pi, because I don't think they're going to be able to stand up to that temperature. But other than that, let me go into logistics. How many people on the team have been to the Cup before?
A fair number of the members have been here. I can count right now, but it should be about half the team has been before.
Outstanding. Okay, so let me just focus on the things that are going to be changing this year from years past. So again, how many people are coming? What's the total number?
24 members.
Wow, big team. Wow, everybody's already paid for?
Yep. We had to finagle our way to get the funding for it, but we were able to get funding for 24 people.
Outstanding. All right. So with that, when are you guys planning on arriving in Las Cruces?
We plan on arriving on the night of the 17th. Ooh.
Okay, so 17th, and that would be Friday?
Saturday before.
Okay, all right. So Saturday, so that gives you some time to do some stuff. Do you already have your rocket motor in hand, or are you getting it from a motor vendor?
We have it in hand.
Okay. You guys are comfortable building that motor, or are you going to be working with a motor vendor to walk you through it?
We're comfortable assembling it. we'll be assembling it with our mentor.
Excellent, excellent. All right, so who is your flyer of record?
Peter Tarley.
Oh my God. I'm so sorry. Okay. Yeah, Peter, I'm just gonna let you know, folks, that young man drives me nuts. Absolutely.
He's awesome. He's helped us out a ton.
He's got a huge heart and he will bend over backwards for anybody, but oh my God, that guy just calls me in the middle of the night kind of stuff. Just for, did you see something on the TV about something, so and so? Hang up, click. Just okay. All right, I will stop that. And Peter will be fine, and I'm glad he's assisting you. I guess that's not too far away from. I mean, he's in what, Chattanooga, and you guys are northwest corner of South Carolina.
Yep. He's at Tennessee.
Yeah, gotcha. All right. And if the rest of your team doesn't already know that, understand that I spent many a year in Charleston. I went to Citadel, and so I married a South Carolina girl, and my two first kids were both born in South Carolina.
Nice.
I cannot stand University of South Carolina, so we've got a lot in common.
Good, excellent. Did you know that we actually we hosted an event this year with the Citadel rocketry team, where we invited a whole bunch of schools from the Southeast to come and test out their rockets with us at a Northfield Air Base in South Carolina. And we did that event last year also, and this was our second annual.
I was told there is no Citadel Rocket Club this year.
So yeah, I'm not sure what the deal with them is. So last year that was their senior design project, and they have all since graduated. And I know that they were having some not issues with the retention, but still maintaining like that partnership with the team. But I'm not entirely sure the logistics of it.
Holy crap. If you talk to any of those big hosers, you need to tell them to call me immediately.
Okay.
Because I mean, I will bend over backwards. I will send rocket stuff to them. I will fund stuff. But again, I was just told there wasn't a rocket club this year, and I started crying. It was very sad because they did so amazingly well in the cup last year.
Oh, it was amazing. They did such a great job.
Believe how well the first year team that have never flown a big rocket before. So anyways, enough on that. So let's see, you're arriving Saturday. That's great. You got 24 people. It's amazing. Peter is your flyer of record. Okay, whatever. But you can't win them all, I guess. Let's see. Starting on Monday, and I'll just start through the critical pieces. On the website, soundingrocket.org, where all the important documentation is, your DTAG, your rules and regulations, all the different there's also an integrated master schedule. That needs to be very, very important. I would wait till about a week after or a week before the event and print that out because we are still making some changes to it. There's also a document on what to wear there, which is critical for your new members. Make sure they don't show up in sandals and freaking tank tops because we will send them away. It's very important they understand what they need to wear. The other part of that is the maps. You guys have been out there before, so hopefully you don't get lost. But if you start to follow Google Maps or Apple Maps or any of that, you're going to end up on a goat path on the wrong side of a mountain because it will not take you where you want to go. It'll be ugly. Reminder that you will be going through a border control checkpoint if you're leaving from. Where are you staying by chance? In Las Cruces or Truth or Consequences?
Las Cruces.
Okay. Are you staying in dorms, Airbnb, or hotel?
Hotel.
Okay. One of the sponsor hotels or just a different hotel you guys picked?
I think it was just a hotel we picked.
Okay. No worries there. A new survey is going out. You guys already did one survey. This will be sort of similar to that, but a final count. So it'll be asking some of the same questions that were asked before. One of the important ones will be a spreadsheet. listing, we need you to list out the first name, last name, and triple ID number of all the people that are coming.
Okay.
Not everybody needs to be a triple ID person, but anybody that's on the recovery team or on the launchpad team that are going downrange must have a triple ID, because you'll get a different style of badge that will grant you access downrange. If you don't
When you
have,
say oh, sorry.
go
When
ahead.
you say ID, do you mean physical ID? As
No,
in like,
no, you'll need I think there is, because with student memberships from AAA, they don't give out physical badges anymore. They don't give out physical IDs. You will have a digital email of some form, I believe, that you'll have to present to ensure that, because what'll happen is the spreadsheet you send us will have the numbers in it. And
Right.
I'm gonna send all of those to AAA, and they're gonna come back saying, this number does not match that name, don't need to have the slightest idea who that person is, or this number has expired, or this
Okay.
number has no membership at all. And so we'll be validating those before you arrive.
Okay.
So we just need something that states your name with that triple ID number, and then we'll be done.
okay,
I
and not
think-
everyone on the team needs one? Because I saw a message go out earlier that everyone on the team needed one.
If you are not going down range, or you are not working with energetics, you are safe. Like, again, if you're helping build the motor, triple ID number.
Okay.
If you're going down range, triple ID number. If you've got a multimedia person that all they're going to be doing is taking photos and video, that person doesn't need to have a triple ID number unless they're planning on going down range.
Okay, sounds good.
All right.
When will that email be sent out? For the
It was
survey?
supposed to be sent out last night, but I got tired. So it's done, it's been validated, and it will be sent out here in the next probably 48 hours.
Sounds good. Thank you.
Yep. Okay, great. So Monday, you guys are going to arrive generally about 10 a.m. The same scenario with parking as we had before. You'll pull up to the back of the convention center, drop off all your gear and all the people, and then only the drivers will return to their vehicles, drive the vehicles to the parking lot that is about 2 blocks away. There just simply isn't enough space in the convention center parking lot, but we have a huge one 2 blocks away. So sorry, drivers, you're gonna have to walk a little bit, but it's survivable. Same scenario on the way out. You take the gear out to the side of the road or to the convention center walkways, and car pulls up, you load it all in and head on out. Monday is going to be a very, very busy day. Registration alone will be a challenge. So make sure you've got everybody's documented information well put together. I put together some kind of binder that has, all those details. Anything that you submitted in email, you might want to have a copy of it. The other piece that would be important would be the liability waivers. Even before you step foot inside the convention center, they're going to be asking for proof of your liability waiver. And that one this year is on spaceportamericacup.com, and it's one of the very top links. When you fill it out, it'll email you a copy of it, and you want to make sure that copy is readily available.
And that's every member needs to fill that out?
Every single member, including your advisors, faculty members, anybody that's going, even spectators. If spectators want to go, they want to be inside the building, they want to go to the launch site, whatever, all of ESRA has to fill it out. Anita, I both have filled it out. So anybody that wants to be involved in the cup has got to fill it out.
Okay.
All right. And so again, shirts, we'll ask again for shirts, sizings, and that kind of stuff, so we can have them all sort of prepackaged for you, so that there won't be too many delays from that. There'll be patches and stickers and swag and some other stuff. With that though, this year will be different because ESRA now has a swag store for both Spaceport America stuff as well as ESRA stuff. So cups, mugs, patches, stickers, shot glasses, expensive. Oh, by the way, Anita, we did get the approval for those fancy satin jackets or whatever they are.
Okay.
So, yeah, those are all done. They're going to be not cheap. They're going to be pretty expensive, but we got them. And a bunch of other neat stuff. So All that stuff will be available for people that, say, for instance, they couldn't make it, or you wanted to get something for your mom and dad, or your little brother, or one of the teammates who had to stay back, whatever the case might be. A lot of opportunities there if you're interested. The store should be opened up almost every single day, Monday, Tuesday, all the way through Saturday award ceremony. Once you're done with that, you have the ability, once you finish registration and you've got all your stuff, you can start setting up your table, your poster session table. So you'll have a standard 8-foot table, a couple of chairs. It'll be assigned to you. You only get one table, you don't get more. Put up whatever posters you want to, set up your laptops. Again, be prepared for Tuesdays, manning that table throughout the entire time, because that's where the judges will come up to you and start scoring you, start judging you for the Rockets and the team skills and teamwork and all of that. One of the last two things that happen on Monday, you'll have a team photo. That's an individual photo of the team. So wear the team shirts, try to comb the hair a little bit, whatever you need to, shave the mornings, whatever you need to do. Just, make the team look good, because we got a professional photographer this year, Jim Wilkinson, who just called me a few minutes ago. They're going to be really great photos. And if you guys look like a bunch of bums, well, I can't fix that part. So anyways, that's the team photo. That does not change anything about the mass photo, the large group photo with all the teams get together. That will be on Monday. That will not be on Tuesday this year. So at the very end of Monday, we're about 4:30 or so, and that's on the integrated master schedule. We're all going to be shepherded outside and put into the huge group and with your rockets, and we'll do the mass photo, which has become a collector's item for many teams. And so the last piece that you can do on Monday also is begin your range safety inspection. So just like last year, we'll have the big room open and available. You just walk in there with your team. They will assign you a table. Your range safety inspection will begin. They'll expect, just like last year, take all the parts apart, and they will do exactly what we did today. They'll ask you tons of questions and inspect all the pieces parts, and they will document any problems that you have that you need to repair. And if you pass the range safety inspection, they'll give you a signature, and you can begin working on flight preparations, which is phenomenal. That's it for Monday. You can take the rocket in on Tuesday during the full convention and have it inspected for a second time if you wish. Again, the sooner you get the sign off, the signature to fly, the better off you're going to be. And that's it for Monday. Once that mass photo is done, you are released. You are free to go. So here's my spiel on what to do. You guys have been there before. Hopefully a lot of you are familiar with the area and what's available there. It's a neat town. It's a college town. It's southern New Mexico, but they have all the Starbucks and all the latest and greatest. I guess here's a good question. Anita, do you know if they have a Dutch Brothers out there yet?
What was that, Andy?
Do they have a Dutch Brothers there?
Yeah, we have 2 now.
Oh my God. So yeah, completely squared away. They've got all the latest and greatest crazes. So there will be a visitors bureau group, basically a city of Las Cruces type group that are going to be serving ice cream on Monday. So go talk to them and say, hey, what can we do Monday evening? Or say, for instance, you have a successful flight on Wednesday or maybe even Thursday. That gives you Friday to go mess around and do stuff. So find out where the museums are, find out, what it's like to go to White Sands and play on the white sand dunes, that kind of stuff. Unfortunately, the Rocket Missile Museum at White Sands Missile Range is shut down, which is something everybody needs to go see. So it's not going to be available. They have a V2, an actual V2 you can put your hands on, which was a heck of an experience for me. But unfortunately, it's not going to be available for you guys this year. Same thing when Wednesday rolls, or excuse me, Tuesday is bright and early. So plan on arriving there around 6:30 in the morning. Opening ceremony will be 7 a.m. And so at 7 a.m., similar to last year, there'll be sort of standing room only, a lot of speeches, a couple range safety things going on, some briefings, and then you'll be released. There will be food available to purchase from inside. It's not cheap. It's good food, but it's not cheap. So a lot of teams want to go out and say, hey, send Stevie out to go get some pizzas. Perfectly okay doing that. You just can't bring the pizza back in. And that goes the same for Starbucks. Somebody wants to run and grab Starbucks for the rest of the team. That's great. It ain't coming back in the building. You got to go outside and eat it. And teams are perfectly okay with that. You know, it's like, hey, it's your turn to go, go eat pizza, and the pizza's right outside the door. The front entrance and the rear entrance will both be available for teams this year. Registration is going to be in a much larger area, so there won't be any of the nightmares of last year. So there'll be plenty of room and space to move around, and everyone won't be trapped outside in the heat. So good. We will make sure. We did learn, and remember, Esra's motto has always been, "It'll be better next year." So that's Tuesday. 4:30 or so, we will boot everyone out. The convention center has another event going on there in the evening, and they want us out there as soon as possible. Once you depart there Tuesday evening, that's it. There's really no other activities going to take place at the convention center at all. The award ceremony on Saturday usually takes place there, but we have moved it to another site. So we will be going that. I'll talk about that in a second at the Pan Am Center, big basketball arena for New Mexico State. So that's Tuesday. Wednesday morning, the gates open at the vertical launch area at 6 a.m. That's as early as you can get in any day of the week. So from that standpoint, if some of the teams wanted to open up or try to get in there at 4 a.m. or 5 a.m., not available. So 6 a.m. is as early as you can get in. And so, make plans for that. If you want to come in a little bit later, that's great. If you want to avoid the crowds, whatever. But the area for the students will be identical. You'll have a 20-foot by 20-foot area to set up. You'll be identified by rows and by team number. So once you find your spot, you may use your car to pull up and drop off your gear, and then go park your car in the parking lot. Canopies, tables, chairs, all that kind of stuff you'll need to bring with you. That's when. So Wednesday launches commence at 12 noon. We will have a slight delay there. White Sands Missile Range just told us that instead of kicking off at sunrise each day, I think Thursday and Friday, we have to wait until 9 a.m., which will really suck. So everyone pray for no rain. That was a nightmare last year. So fingers crossed. I would take 110, 115 degree day any day of the week before I want to deal with a rain day, because that was not fun. So you have the opportunities to launch on Thursday through Friday. If you haven't flown by Friday afternoon, I would be sounding the alarm. Major issues. Cannot promise anybody will have the opportunity to launch on Saturday. Because it stops at 12 noon and there'll be tons of other teams trying to get in. So if you have an option to fly Friday or Saturday, always go with the earlier date. Earlier date, you better off you're going to be. Saturday evening Saturday will shut down at 12 noon. And if any teams want to help us clean up, we always give some type of team bonus points for groups that do that. If we get 3 or 4 big teams to help us take stuff down, that's a huge win, and we can get it all done in about 2 hours. That'll give us enough time to get back to Las Cruces, take some showers, get cleaned up, and I think everyone's supposed to meet at the Pan Am Center at 6 p.m. I think. I can't remember. It's on that schedule. There won't be any ice cream on this event. They got cheap on us, or they charged too much, and we told them no. Let's see, this year there will be a live stream. It'll be even better than last year's live stream. Hopefully you guys saw some of that. Live stream had close to 100,000 viewers last year. At one point we had 6,000 people watching. So we're asking all the teams if they have the availability to give us some kind of introductory video, a 15-second or maybe a 30-second video clip that introduces the team. The goal is while you're walking out to the pads, instead of us just saying, up, there goes team 22 from Saskatchewan University, we could actually be playing your video. And that makes the folks at home and everybody else get real excited.
What's the deal with music on that video? Are you allowed to put any copyrighted music on it?
No, negatory. Any copyrighted music will be basically we'll either mute it completely so there's no music at all or no sound at all, or we won't play it.
Okay.
So you guys know the rules on that one.
Yep.
If any music that you do play on it, I would put at the very end of your video just a little snippet on the bottom of, what song it was, who was the author, all that kind of, basically the media rights from it, so you can be safe. That way, if YouTube comes back and says we can't play this, and because the problem is, all it takes is one little clip of our copyrighted video, and YouTube can block our entire live stream. And so that's not good.
Okay, better be safe than sorry. Another question I have about live stream is there going to be on ground footage? So I know last year they had the drone footage, but are there going to be any cameras set up at the rails to be able to record the actual launch and takeoff of the rocket from the pad?
Absolutely. So we actually did last year as well. The solids pads, there'll be, I think, almost 20 pads in one specific area of the solids. Last year, we tried to break it up to have 2 separate areas of solids, and that just turned into a disaster. So this year, all the solids are going to be out on the right. If you go down that main road, it'll be all the way to the end to the right. So we'll have 20 pads out there. We'll have 2 large PTZ zoomable cameras out there, a bunch of still cameras in addition to the in addition to the drones. So we'll have, we should have good footage of all of the teams. One of the requirements though was that the team number be identified on the rocket between all the fins. And the reason we do that is because if you just put it straight dead on the rocket, it's really hard for us to see it if the camera is off at an angle. But if you put it between all the fins, then we can see it at any angle.
Okay.
So that's one of the things, and make sure that it says it in the rules. It tells you how big the numbers need to be, that kind of stuff.
Are you providing the numbers or no? I know last year.
No, you guys need to. We'll have numbers on the pad. I mean, like pad 6, pad 7, but not putting any. We will not provide any numbers for the numbers on the rockets.
Okay. Just out of curiosity too, is there footage? Where can you get footage from last year's launch? Because we never received any footage of the rocket taking off the pad.
So you won't get anything specific. What's posted, you want to make sure you subscribe to our YouTube channel. And if you go into the Experimental Sounding Rocket Association YouTube channel, then there's a couple of different set versions of that. You want to find the one that has 2,200 subscribers. Because there's one there that's like 8 subscribers, and another one that has no subscribers. So the one that has 2,800 subscribers, 2,200 subscribers, that has all of the videos. There are literally hundreds of videos. Scroll through that list, maybe even look for the list of lists, and you'll find one for the live stream from 2022. And there's a stream for each day, and they're like 8 hours long. And I think if I remember correctly, we did index them. So if you look through the indexes, it'll tell you all the teams and what time they launch inside the video.
Perfect. Okay. I think we did look at it last year, but didn't see anything. But I'll look through that again.
Yep. All right. I think the last little piece was the award ceremony. A lot of teams decided that, hey, it's not that big a deal to go to that, and I'm real tired, and it was wet and yucky, and we didn't have a good launch, so screw it, we're not even going to go to the award ceremony. Well, guess what? Your team won a sportsmanship award or won some other kind of award, and it's just really, really embarrassing to the team and to our event at the award ceremony when we call out your name and you're not there. So I would please, even if you just have to drag out, a few individual members, still up to the awards. It's a lot of fun. We try to make it fun, and we understand that a lot of teams, didn't do as well as they'd hoped, et cetera, but you know, if you think you got a shot, you should absolutely go and cheer everybody on. But you know, please do your best to make that is part of the event. And we do notice when teams are not there. So just to let you know. All right, you planning on departing on Sunday?
Yeah, that's the current plan.
Okay, and y'all are driving or flying?
Driving, sadly.
Oh, yeah, road trip, baby. That's
Yep.
a couple of days of, yeah. So be very careful on the drive. You know, please, I beg of you, don't drive round the clock, even if you have 5 or 6 drivers. You know,
We're
give
stopping in
everybody-
Fort Worth,
I got
Texas.
you. Okay, yeah, that's still a long drive from there to there because I've done the Charleston to Houston drive a few thousand times, so I know.
Yeah, it's pretty terrible.
That's
Oh, yeah,
further, I
absolutely.
think. So
So, all right, I think that's it from my side. Anything, Anita, that you wanted to add?
No, you covered it all, Andy. If the team has questions, this is an opportunity for them to ask even more.
Awesome.
I don't have a question, but I have a video of that payload working if you want to see.
Oh, yeah, absolutely.
Yeah.
Sorry, I have a question. Andy, we were talking, I was the person that emailed you about DaVinci never contacting me back.
Yeah.
They did reach out, but you know when we'll receive, like, you are assigned this, like, specific frequency? That seems how they advertised it, or I guess I need a little bit of clarification as to how all
Well,
that.
no, you should have already received your frequency. So if you have not, let me give you the email address. Did I give you this before?
So you CC'd me, you CC'd them with in the email, but the last email I got is the is the reminder. I believe it's the reminder 2. I might have, and then they emailed me back saying it's complete. Make sure you have everyone and take the training, but I never got a like this is your specific frequency email.
So you guys are using a featherweight though, is that correct?
Yeah, so we have 2 featherweights, so that's both 33 centimeters, and then we have our own our own SRAD telemetry system, plus the Cricket will have its own telemetry for GPS that's 70 centimeter band.
Oh, wow, crap. Okay. So the email that I sent should have a email address in it for frequencies at DaVinci Maker Labs.
Okay.
So just here, again, if you get a response back from them, send a note to them saying, hey, we're still waiting for details on what we're supposed to do, and make sure I'm in the CC of that. And that way, if we don't hear anything back, I can go smack them around.
Okay, I can send that email tonight, probably.
Yeah, the good deal is DaVinci is right here in Houston. So, and I know Chris Harris pretty well.
Okay, thank you.
Absolutely. And again, you're doing the right thing. Don't let that sneak by. You want to make sure you get that closed loop long before you guys depart.
Thank you.
Yep.
Here's a GIF of that payload. This is a test tube. I believe this was the test tube. It wasn't the actual tube
So,
that it's in.
how quickly does it, I mean, is it like a second or two, or does it take longer to do that?
I mean, we have control over how long it takes, but
Okay.
we're hoping to be pretty quick. This video shows it retracting a lot faster than extending.
Right.
I don't want that to happen ultimately. I'd rather they comes out the same speed as it goes in.
Oh yeah, absolutely.
That's something we're still playing around with.
You have that in some kind of horizontal function on the table, and you guys are hitting the little button to make it go in and out like that. You're going to have all sorts of people around you.
Okay, good. We printed out a whole bunch of stickers to give out to people, so
Nice. Absolutely.
getting the Clemson merch ready.
Nice.
Yeah, and they haven't been ordered yet, but the idea is that last year we wore polos to the presentation, but this year I think we're going to go with a Hawaiian shirt theme. Keep it a little fun and put some lays on. And Figured it'd be a little different.
Excellent, excellent. I like it. Creativity is always awesome. All right, guys, I've got dinner getting cold over here in my hotel room. Any last questions for me? Nope, going once, going twice. All right, well, good luck, guys. This concludes the video safety presentation. I have
Awesome.
13 minutes to eat my dinner before the next meeting.
Jeez.
So
All right. Well, thank you